Example 5.1. Unpolarized light is sent into a system of 3 polarizing sheets. All angles are measured counterclockwise from the y-axis. Angles theta 1 and theta 3 are fixed, but angles theta 2 can be varied. The plot gives the intensity of the light emerging from sheet 3 as a function of theta 2. A. From the intensity plot, what are the possible orientations of the first and third polarizers? B. Fix the angle of the polarizer number 2 to 30 degrees. Now, draw an accurate diagram of the polarizations of the light after each polarizer. What percentage of the light initial intensity is transmitted by the 3-sheet system? By looking at the intensity curve, at theta 2 equal to 0 degrees and 90 degrees, as well as 180 degrees, the intensity is 0. What are the possible combinations of polarizers number 1 and number 3 such that they agree with the intensity curve? Okay, so let's look at that. So what we're going to see here, so if I just put in my curve here, I'm going to keep that right here just so that we always have it. What we're finding here is that we're going to see here that polarizers number 1 and number 2, the angle between them is going to be theta 1 and theta 2. So these two, they have to guarantee intensity equal to 0 at theta equal to 0 degrees and 90 degrees. The third one hasn't even come into play. So then, when I now look at the polarizer 2 and 3, then we have to worry about the angle 2 and 3. So this guy, it has to guarantee that the intensity is equal to 0 at only 180 degrees. So what we want to do then is that we need to look at those two situations here. So let's start with polarizers 1 and 2. So here we go. So now we're looking at polarizers 1 and 2 combinations. So what are the possible combinations that I can have theta equal to, intensity equal to 0 at theta equal to 0 and theta equal to 90? So let's draw them in. So the first thing that we got to do is that I'm going to set up a polarizer and I'm going to draw them all the same. So I'm going to copy this just to make things fast. So here's my polarizer. Now I haven't put any of the gradings, But what I'm going to do here is that I'm going to copy this so that I have the ability to paste this in to not waste your time. So here, how can I get theta equal to, the intensity equal to 0 at theta equal to 90 degrees? So one combination is that I can make this guy a vertical polarizer, and this is going to be number 1. So what I'm seeing here is that I have intensity coming in, and this is unpolarized light with initial intensity I naught. Now, because of the way we set this, remember, everything is measured relative to the vertical axis. So that means here is that theta 1 here is 0 degrees. Now what happens here is that this light, the only light that's going to pass through is the horizontal light like this. And that's going to come in with some intensity 1. Now let's draw in the next polarizer. Whoops, well, I'll have to draw it by hand again. So I'm going to go from here, and it's going to look like this. So if I look at this guy, I'm going to make this so in order to have the intensity be 0 at 90 degrees, I have to filter out this horizontally polarized light. So then I'm going to make this a horizontal polarizer like that. So when I look at this, you could see that this angle here is theta 2, which is 90 degrees. That's polarizer 2. So when this goes through, the intensity here is 0. So now if I have a third polarizer here, note that it doesn't matter now, because now this polarizer is going to have an intensity 3 of 0, since no light gets in at that point. Okay. Now there's another combination. So I should be careful, and I should say this. So here, this angle theta, so this orientation does not matter, because there's no light going through that polarizer. So I can have a third combination, a second combination of these three. And again, I have unpolarized light coming in, and it has intensity I naught. So then I'm going to put in my 3 polarizers. So here's 1, 2, and finally 3. So how can I get the zeros at 90 and 180 degrees? So instead of it being vertical, I could have chosen this guy to be a horizontal polarizer. So if you look at this, then this combination here is theta 1 equals to 90 degrees, and I can choose this guy to be a vertical polarizer, which again tells us that theta 2 here is 0 degrees. So when I look at the light as it's coming through, I get vertical light that comes through. So then I have vertically polarized light, which has some intensity. But now when it goes through this polarizer, number 2, you could see here, it's going to filter out all the light. So once again, theta 3, its orientation doesn't matter, because regardless, I'm always going to get intensity of 0. So what you're seeing here is that the combination between theta 1 and theta 2, so the combination of the combination of angle between polarizers number 1 and number 2 is I could either set theta 1 equal to 0 degrees and theta 2 equal to 90 degrees, or I can choose theta equal to 90 degrees, theta 2 equal to 0 degrees. That combination does not matter how I do it. Now I got to worry about the 180 degrees. So here I go. So now what I'm going to look at is I'm going to look at polarizers number 2, number 3 combinations. So this guy has to guarantee that 180 degrees is 0. Okay? So here I go. So now what I'm going to do is I'm going to do exactly the same thing that I did up here. So the way I'll look at this thing here is that I'm going to set up my polarizers now. Here I go. So here's one. Putting these guys into place. So now let's go look at these guys. So what I'm seeing here is that I have some intensity that's going to be coming through that's I naught. So the only thing I know is that I don't know what the, I don't care about what the polarization of 1. I only care about the combination of 2 and 3. So if I choose this guy to be horizontal, then regardless of what happens, this intensity 1, which is not 0, is then going to have a component that comes in that's going to be vertically polarized. So all of a sudden, this intensity is not 0. So then to kill this off, I need a vertical polarizer so that it filters out that. So now the intensity here is 0. So again, this guy, as I said before, this orientation does not matter. This guarantees 180 degrees equal to 0 here. Now, the other thing that I could do here is that note that I can reverse this combination. So if I come in and I stick my 3 polarizers here again, just as I did before, now I can have the same type of situation. So you could see what I'm going to do here is that I'm going to reverse it. Right, so I'm going to move this over just a tiny bit. And what we're seeing here is that we're seeing this. I have unpolarized light. Because the orientation doesn't matter, all I know is I'm going to get some light that's going to come through. Now, to guarantee 180 instead of a horizontal polarizer, I want a vertical polarizer here. And then the third polarizer, I'm going to make a horizontal polarizer. So now I have this combination, which then guarantees then as the light comes in through here, right? As the light comes in through here, this guy is going to get filtered out and then cause this guy to be 0, which is exactly what we want. So then we could see here is that the combination of polarized polarizers number 2 and number 3 is that I can choose theta 2 equal to in this case 90 degrees. Again, remember, this is 90 degrees. And then this guy here is 0 degrees. Or I can choose this angle, theta 2 equal to 0 degrees, and theta 3 equal to 90 degrees. So then this case will be theta 2 equal to 0 degrees and theta 3 equal to 90 degrees. So now, what combination? Well, if you look at the combination here, I could set this up any way that I want here. So the question then comes in, which combination of polarizers will now guarantee intensity equal to 0 at theta equal to 90 degrees and 180 degrees. So I need that combination. So here's what I have to do here. So if I choose, so there's two choices. So the first combination, I would say, if theta 1 is chosen to be 0 degrees, then the only guaranteed combination that I'm going to guarantee at 180 equal to 0 would be theta 3 equal to 90 degrees, not 180. Or I can do the opposite. If theta 1 is 90 degrees, then I can guarantee if I choose this to be 0 degrees. So because I can choose whatever I want, this is the combination I choose right here. Either one works just fine. So with that being the case here, then here's my combination now. So my 3 polarizers now look like this. Okay, so I'm gonna come in here, I'm gonna paste this guy in. Okay, here's 1, here's 2, and then the last one, so I'm gonna put right here. So now that I have that, this is polarizer number 1, number 2, number 3. This guy is now fixed to have theta 1 equal to 0. Now, theta 2 theta 2 is variable. So if I rotate this thing 90 degrees, then I get 90 degrees equal to 0. Now, this guy has to be rotated 90 degrees. So this is my possible combination. And what I'm saying here is that when I look at this thing, let me get my curve here, and I come down, this curve is going to be produced by these polarizers. So if I send unpolarized light here, I naught, that curve on the right will be given by this combination. So now that I have that, then let's get started here. So now what we're going to do here is that we're going to do part B now. So in part B here is that now we're going to draw the polarized / filtered light after each polarizer. Okay, so now I need these guys back. So I'm going to copy these. Okay, I'm going to copy these and I'm going to paste this guy in right here. Now, what am I looking at right here? What you're looking at here is that now I'm going to fix this angle. So I'm going to take this guy and it says I'm going to fix theta 2 to 30 degrees. So what does that mean? So here's my 0 degrees. So what I'm looking at is I'm going to say that, well, this angle here is theta 2, which is now 30 degrees. So when I look at my polarizer, it has to have this 30-degree angle right here. So now what does the light look like? So what I'm seeing here, as the light goes through the first polarizer, only the horizontal component actually survives. And this is going to give me intensity 1. So as it goes through the second polarizer, only the perpendicular component survives. So that means here that I'm going to get light that now looks like this. And that's going to give me intensity 2. And then as I come through the third polarizer, only the vertical component will survive here. So then that means I'm going to get light like this with some intensity I3. So each of these does not have a full intensity, and that's exactly what we're going to calculate. So now what we want to do here is that we want to calculate the relative intensity I3 over I0. That's what we want to do. So let's go look at that thing. So here we go. So what we're going to see here is that the first thing that we do here is that we got to look at what happens to the light after polarizer number 1. What it does here is it removes half the light. So that tells me here is that the intensity I1 is 1/2 I0. But if I write this, it really tells me that I have I1 over I0 is equal to a 1/2 factor. Okay, so then I'm going to go through polarizer number 2. So this guy, what we then says here is that it filters out a cosine squared, it filters out a cosine squared quantity. So what do I mean by that? Well, it tells me that if I have, so by the way, I should be boxing these because we're going to need them. So if I filter that out, it turns out that the intensity 2 related to the intensity 1 is the cosine squared of the angle between the two filters, theta 1 and theta 2. Right? So once again, this is the angle between polarizer number 1 and polarizer number 2. So when I look at this thing, then this tells me that this is the intensity, and you can see that there's an angle of 30 degrees. So it's going to be 30 minus 0. So if I keep writing this, look what this says here. That this is really equal to what? So if I look at the relative intensity is then going to be, it tells me that I1 over I2 should then be cosine squared of 30 between filters 1 and 2. Now we get to the third filter, and this is again following the same process as before. This again filters out a cosine squared quantity. You know, that's a misleading word. It's not filters out. It lets through a cosine squared quantity. So the word filters out is not correct. So then if I look at this here, it's theta, I3 isn't going to be I2, and then this guy is going to be the angle between 2 and 3. So again here, once again, this is the angle between polarizers 2 and 3. And if you look up here, you could see that the one is 90 and one is 30. So in this case, this guy's going to be I2 cosine of 90 minus 30, which then tells me that the relative intensity between 3 and 2 is then going to be cosine squared of 60 degrees. So now I can put these all together. And if I put these all together here, we then say this. The relative intensity I3 versus I1 is then going to be this. So I3 versus I1, it goes through the first filter, which gives you a factor of 1/2. Okay, this guy's going to be my factor of 1/2 from the first filter. Then I get a second term, and that second term is the second filter, which gives me a cosine squared of 30. And then finally, I go through the third filter, and that one gives me a cosine squared of 60. So when I multiply these all out together, I get 0.094, which then tells me that I3 divided by I9 says that only 9.4% of the initial light is what actually makes it through the 3 filter system.